Okay, here we have a factor completely problem, and what I want you to notice is this is a binomial. Notice it's only got two terms. And the very first step to factoring a problem, whether it says factor completely or not, is to see if the problem has what we call a greatest common factor. Is there something common to all of the terms that you have? Of course, we only have two terms in this case. And what I notice is that 3 will divide into both 3 and 192. They don't both have the variable, but they both have a 3 in common here. So I'm going to pull out that 3. So in other words, I'm going to dividing each of these guys by 3. And when I pull out that 3, these 3's cancel. I'm left with t to the third. And 192 divided by 3, you might want to visit your calculator for this, is 64. So you get plus 64. Okay, so we factored out the greatest common factor, but then I'm charged with possibly factoring this again. How do I know it might factor again? Because this variable is raised to a power, which indicates to me that, hey, this might happen again. Now what you have right here, t to the third plus 64, that's called a sum of cubes. And there's a special formula for a sum of cubes. And the special formula is if you have a to the third plus b to the third, the formula is a plus b, and then times a squared minus ab, let's put a 2 there, so minus ab plus b squared. Okay, now I don't think about it in terms of that so much. What I do think about it as is the cubed root of this one goes in this spot. The cubed root of the second term goes in the second spot. And then here you square the first one in line. You multiply them together, change the sign, and you square the last one in line. So let's try that for this particular problem. So this is just a formula that we're going to do for this particular problem. So the 3, now it comes straight down, and remember I'm going to have a short set of parentheses and then the long set. Short set meaning the binomial, long set meaning the trinomial. So the cubed root, sorry about that low battery thing, I had to fix it. So the cubed root of t to the third is t, and the cubed root of 64. So again, when you do a cubed root, you're asking yourself, what value, the same value, do you multiply 3 times to get 64? Like t to the third is t times t times t gives me t to the third. 64 is 4 times 4 times 4, right? Because 4 times 4 is 16, and then 16 times another 4 is 64. So that is 4. Now whatever operation is here moves on down. So we've got this part handled, the a plus b. Now I'm going to work on the a squared minus ab plus b squared. So it says the a is squared. What is a in this case? It's t. So I square the first one. Okay. And then let's go ahead and go to the end and square the last one. So 4 squared is 16. So you square the first one in the first position, you square the last one in the last position. What goes in the middle? These two multiply together. So t times 4 is 4t. Now let's talk about the signs. If this is plus, then that changes to minus. And this last one over here, no matter what your original problem is, that's always positive. So even if you had a problem that was t to the third minus 64, then that would always be plus. But if it were a minus, let's just say, what if we had t to the third minus 64 instead? Again, that factors into a short set and a long set. The cubed root of t to the third is t. The cubed root of 64 is 4. If there's a minus here, there's a minus here. Then remember, you square the first one, so it's t squared. You square the last one, so that's 16. Then you multiply those together, which goes in the middle. But since this is subtraction, you change the sign here. That's addition, but the last term is always plus. So notice the difference. Okay, the red, again, is just a completely separate problem. Hope this helps you out. You have a wonderful day.